We exist interior a swirling platter of 400 billion ACE. The Milky Way reaching 100,000 light-year, from edge to border. That sounds massive, right? We can see of the universe beyond its 93 billion light-year crosswise. Notably, and scientists believe the actual universe power be space. We will journey from our astronomic abode to structures so immense they make our colt's foot vanish, like a grain of sand on an
In the
endless
silence
beach.
of space, a new
Hit that
journey
like button and
begins.
subscribe
Thrusters
if you
ignite,
enjoy this
propelling the
journeying through the
probe
cosmic
toward the
void
unknown.
series.
The
But here's
cosmos
what's interesting.
awaits.
Let's get down. Notably, picture yourself standing in a battleground at midnight, staring up at the river of visible radiation cutting across the sky. That band of stars is the whitish way, our place galaxy seen from inside. You are looking at the border of a disk spinning through the void. And everything you see with your eyes belongs to this single structure. Certainly, the milk-like way measure roughly 100,000 light-age from one bound to the other. To cross it at light source fastness would take 100,000 years of uninterrupted traveling. Scientists have confirmed this measurement by tracking variable ACE-call Cepheids, whose brightness pulses in predictable shape. Obviously, each pulse tells us exactly how far away they sit. Our galaxies between 100 trillion and 400 billion star. Sometimes, each one is a nuclear furnace, many with their own planets. Most of these ACE cluster in a flat record, only about 1,000 light-year thick at the arms. At the center sits a bulge roughly 10,000 light-years wide, packed with antediluvian red stars, and predominate by a cracked massive black hole advisement, Capricorn. We live in a barred spiral coltsfoot. But the seeable disk isn't everything. Recent simulation reveal that dark matter surrounds the Milky Way in a massive halo extending nearly 2 million light-years outbound. This unseeable stuff creates the gravitational skeleton holding our galaxy together. Without it, the outer stars would spin off into the darkness. We cannot see this halo because dark matter doesn't emit light. Yet, its gravity contour everything. Definitely conceive of our colt's foot as an island in a iniquity ocean. No doubt 100,000 light-years of a depth and gas wrapped in an invisible sphere, 20 times wider. That island seems tremendous until you realize the ocean reaching in every direction for distances that make our home look like a floating speck. Right now, tons of smaller galaxies sphere the Milky Way like moths circling a flame. The largest, the large Laniakea kind of cloud, measure 32,000 light-year crossways. Most dwarf galaxies hardly 500 light-years broad. They'll finally be snapped apart and consumed by our colt's gravity. This has happened before and will happen again. But if the whitish way is just one island, how many others float in that ocean? The answer changes everything we thought we understood about our place in creation. The evident universe measures 93 billion light-year in diameter. Let that number settle. Not 93,000, not 93, no 0,01000, not 93 trillion light-years to the other, with Earth roughly the middle of what we can see. Actually, this creates a comparing that shatters suspicion. The Milky Way spans 1,000 light-year. The observable create spans 93 million light-year. Divide those numbers and you get 930,000. The observable world is almost 1 million times wider than our colt's foot. To be honest, if the Milky Way were the size of a quarter, the observable universe would stretch farther than from Earth to the Moon, then Dorsum, then to the Moon again. Here is where it gets alien. Scientists confirm that light travel at exactly 186,000 meters nothing moves fast. The existence began expanding 13.88 billion years ago, in what we call the Big Bang. Logic suggests that light could only have traveled 13.88 billion light-source old age in any direction, devising the universe about 27 billion visible light-age crossways. But that logic ignores one critical fact. Infinite itself expands. Generally, while light travels through space toward us, the space buttocks it stretches, pushing the source farther away. Objects that at light 13.888 billion age ago have now moved to positions roughly 46 billion light-year distant. Manifold by 2 to account for all directions, and you get 93 million light-year. This is corroborate through measurements of the cosmic microwave oven, backration, and redshift calculations from remote galaxies. Consider this visualization. The observable universe would be about the size of our full solar system. If you could shrink world to the size of a virus and keep that scale consistent, a virus compared to the distance from here to beyond Pluto, that represent the scale between our world and everything we can detect. Look, every sec, the discernible existence grows. Look, light source from more remote part finally reaches us after traveling for billion of old age. Importantly, the border of what we can see expands by tierce visible radiation seconds per sec. That's 560,000 meters every tick of the clock. Truth is, we are observation the cosmos unfold in real time. Plus, but we will never catch, up to its true size, and the observable yearly what light has had time to range us from. The actual universe extend beyond that horizon, perhaps infinitely. Every computation we make, every measurement we confirm point to one conclusion. We can see only a tiny fraction of what exists. Think about it this way. The Milky Way is vast beyond rule comprehension. But compared to the universe about it, our galaxy disappears like a ace cell in an ocean, and that ocean contains structures even more staggering than the space between them. Plus, 1 light-year equals 5.8 trillion miles. That single unit of measurement, 5.8 trillion miles, represent the distance visible light travels in 165 days of continuous motion at 186,000 meters. In fact, to cross just 1 light-year would issue a Bodoni spacecraft, roughly 70,000 old age. Visible light from our closest neighboring star, Proxima Centauri, takes 4 years to scope globe. When you look at that at depth through a telescope, really you see it as it appeared 4.2 eld ago. The visible radiation hitting your eye left wing that star before you started reading this sentence. Here's the bottom line. Indeed, astronomers call this looking back in time, and every observation we shuffle of distant objective. Besides, corroborate it, the Milky Way is 1,000 light-years across. Basically, light one edge would not reach the reverse border until 100,000 old age of traveling. If humans on opposite sides of the galaxy tried to have a conversation, each message would arrive 50,000 years after being sent. Really, empires would rise and fall between query and answer. Importantly, now scale of measurement that up. The close large galaxy to us, Pieris Japonica, sit 0.510000 light-age away. The light we see from Andromeda left that galaxy before humans walked upright on Earth. We observe antediluvian history when we look at the dark sky, and the farther we aspect, the deeper into the past we peer. The Virgo cluster of galaxy lies 54,100,000 light-age distant. Visible radiation from those galaxies get down its journey before the asteroid struck Earth and ended the dinosaur. The most distant confralax sit over 13 billion light-year away. Their visible light started traveling toward us when the world was scarcely 700,000 years old, less than 5% of its stream age. This creates unknown realism. Astronomers don't investigate the universe as it is now. They study a creation that survived billions of age ago. The further away an object sits, the younger it appears. The edge of the observable existence demonstrates us the cosmos 13.88 billion years ago, shortly after the Big Bang. What those regions look like today, we will near cognize. The light source showing their current state, won't reach us for billions more eld. Plus, but here is the savage twist. Surprisingly, space expands faster than light can travel at extreme distances. Surprisingly, galaxies beyond a sure point are move away from us faster than light can close the gap. Their visible light will never reach us. They live beyond a cosmic view we cannot cross, no matter how long we wait or how advanced our telescope become. Every photon that reach Earth has traveled unimaginable distances through expanding space to get here. Light connects us to the universe, but it also reveals how isolated we really are. The Milky Way sits in an ocean of space so immense that most galaxies will forever remain unseeable. Yet in that ocean, sustained by decennium of observation, 2 trillion galaxies shine. And most of them are hiding from our view right now. The evident universe ends at 46 billion visible light-years in every direction. This isn't a physical wall. No barrier marks the border. Or else, it is a skyline made by the main laws of physics, confirmed through cosmologic computing and observations of the cosmic microwave ground. Here's the deal, light can only travel so far in a universe that's 13.8 trillion years old. Combined with the expansion of infinite, there's a uttermost distance from which light has had time to reach us. Beyond that distance, galaxies survive, but their light has not yet arrived. Those galaxies lie outside our observable universe. As well, they might as well subsist in another reality. Here is what brand this boundary cruel. The universe is expanding, and that enlargement is accelerate. Dark energy, an inscrutable force, confirmed through observations of distant supernovae, push space apart faster and faster. This acceleration agency that galaxy near the border of our discernible existence are receding from us at speeds approach the speed of light. Some have already crossed the threshold where their recession speed exceeds visible radiation speed. When in the galaxies that limit, unknown thing happen. The light it emits can theoretically reach us, but it gets stretched by spread out space. The wavelength grow longer and yearner, shifting from visible light to infrared, then to wireless waves, then to wavelengths so long our instruments cannot observe them. Sometimes the galaxy fades from vista, not because it stops shining, but because infinite itself transforms its light to invisibleness. Often, scientists have calculated a futurity profile bound at roughly 62 billion light-year. Galaxies beyond this distance will never enter our evident universe any point in the future. Because space between us and them expands too fast, the light they emit today will never reach Earth. We are surrounded by an sea of galaxies we can never see, separated from us, not by physical distance solitary, but by the very fabric of space maturation between us. This creates an isolation more profound than simple distance. Just about 90% of galaxies in the discernible world today will eventually fade from view. As space continues to expand, they'll redshift into darkness. Futurity civilization, if any subsist, will look up at a sky containing only the galaxies in their local group. Plus, they'll see a universe that appears small, quiet, and most empty. Certainly, we live in a unique window of cosmic time when the creation is old enough to have formed composite structures, yet young enough that we can still find distant galaxy. To be honest, in some other 100 million old age, most evidence of the Big Bang will have stretched beyond detection. Futurity uranologists might reason they live in an atmospheric, lonely creation containing only a handful of nearby galaxies. But the true upsize of the universe extends beyond this observable boundary. Besides, most estimates propose the entire universe could be at least 250 times bigger than what we can see. At the end of the day, theories push that figure far higher, One computation places the full existence at 10 million trillion multiplication the size of the observable region. Without question, and that assumes the universe hasn't it at all. Of course, many cosmologists infinite continues infinitely in all directions. Importantly, meaning the universe has no size, pretty much, no center, no boundary. We simply live in one region of an endless expanse. The truth is, what's more, Milky Way sits inside an observable 93 light years. But that bubble power typify less than 3% of reality. Everything else remains forever beyond our reach. Truth is, the discernible universe contains at least 2 trillion galaxies. This figure comes from decades of observations, primarily using the Hubble Space Telescope, combined with mathematical models that account for galaxies too swoon or distant to detect directly. And here's the thing, researchers corroborate this estimation in 2016 after analyzing deep space image and converting them into three-dimensional maps of galaxy dispersion. 2 zillion correspond a tenfold increase from former estimate of 200 billion galaxies. The truth is, definitely, the difference comes from improved sensing of small syncope galaxies that earlier study missed. Usually, most galaxies in the universe aren't giants like the Way. They're dwarf galaxies containing only millions or billion of stars, rather of hundreds of billion. Of course, these smaller galaxies dominated the early universe and unify over time to form larger structures. Think about it this way. But evening 2 trillion is likely an underestimate. The calculation only accounts for galaxies we can, theoretically observe with current or near-future technology. Approximate 90 of galaxies in the observable universe remain too faint and remote for our telescope to find. They exist beyond our instrument's reach, invisible until we develop more powerful tools. The James Webb Infinite Telescope is outset to reveal some of these concealed galaxies, but most will stay invisible for generation. Truth is, each galaxy contains an average of 100 million stars. Think about it this way. Some nanos galaxies hold fewer than 1,000 ACE. Of course, giant elliptical galaxies can contain over 100 trillion stars. Multiply these ranges across 2 million galaxies produces a flounder estimate. Usually, the observable universe probably incorporate around 700 sextillion stars. That number 7 followed by 20 zeros exceeds the totality grain of sand on every beach and desert on Earth. Let me put it this way, and those are just the star we can theoretically count. Around each star, planet may orbit. Holocene surveys suggest most stars host at one planet. What we're seeing is, if evening a fraction of those 2 trillion galaxies, comprise 100 trillions each, and most stars have planets, the figure of worlds in the universe becomes nearly meaningless. It drowns in its own scale of measurement. The distribution of these galaxies isn't random. In fact, they cluster together in grouping which gather into clusters, which form superclusters, which arrange themselves along huge filaments separate by tremendous voids. Usually, the cosmic web, as astronomers call it, displays galaxies strung like lights on threads stretching across hundreds of millions of visible light years. Between the threads, huge bubbles nearly empty space-span distances bigger than the Milky Way many thousands of multiplication over. This construction confirms what Reckoner simulation predicted. Wickedness thing creates the framework, its gravity pulling pattern, matter, into dense node connected by filaments. Galaxies form where dark thing accumulates. The void exists because wickedness matter is sparse, giving soberness less material to work with. Think about it this way, generally, but here is the trouble world. We can see 2 million galaxies now. As the universe expands and galaxies accelerate away from us, more and more will cross the cosmic skyline and disappear. In the trench hereafter, observers in the Milky Way will face out and see only the few dozen galaxies in our local, anesthetic gravitationally bound grouping. Everything else will have redshifted into invisibleness. The universe teems with galaxies, each one a various island containing million or trillion of ACE. Also, and the whitish way is merely one of 2 trillion such islands, most of which rest hide in the shadow. But cognize other galaxies survive is different, basically, from understanding how they relate to us. Our galaxy doesn't float alone. It belonged to structures inside structures. Now, here's where it gets good. Each one larger and stranger than the finale. Think about it this way. The Milky Way you see in the night sky is a lie. Well, basically, not exactly a lie, but an incomplete image. The visible platter of stars and gas represents only a fraction of the galaxy's true extent. Surround everything we can detect sit an enormous halo of data arrival outward, about 2 million light-year age from the galactic center. Dark matter doesn't emit light. It doesn't absorb visible light. It doesn't interact with electromagnetic radiation in any way we can presently detect. Scientists cognize it exists because of its gravitational effects, which are undeniable and confirmed through multiple independent observations. If only visible matter existed, stars at the outer boundary of galaxies rotate faster than they should. Something unseeable must be adding batch and gravity. Computer simulation unveil that dark matter halos about galaxies should extend far, far beyond the visible disk. Recent studies confirm this by tracking the movement of satellite galaxies orbiting the Milky Way. These dwarf galaxies move in ways that only brand sense if a monolithic dark thing halo pulls on them by measuring their velocities and trajectories. Astronomers calculated the aureole's size, approximately 9 million light-year age in diameter. Often, this nimbus contained more mass than all the ACE, gas, and debris in the visible galaxy combined. Estimation advise wickedness matter makes up 85% of the whitish way's total batch. The stars and planets, everything we can see and touch, amount to less than 15% of the galaxy's gravitational presence. We inhabit inside invisible construction, like insects crawling through the skeleton of a beast we cannot perceive. The dark affair halo isn't uniform, and here's the thing. It concentrates more thickly, come on the center, and thins out toward the edges. Flush at its edge, nearly 1 million light-years from the astronomic primary. The halo's sobriety influenced nearby gnome galaxies. Some of these small galaxies are being slowly ruptured apart by tidal forces. I intend their stars stripped away and assimilate into the Milky Way's outer part. This process has happened many times before. In fact, astronomers have observed streams of stars flow through space around our galaxy. The remnants of nanoscale galaxies, actually destroyed millions of years ago. As they spiraled inward, these stellar streams trace the way the doomed galaxy take. The Milky Way grew larger by devour smaller neighbor, and the dark matter halo helped trap them. If the visible Milky Way is 100,000 light-year crossways, and the wickedness matter halo extends to most 2 billion light-year, that brand our galaxy 20 times wider than it seems. Suddenly, the Milky Way isn't just one island in the cosmic sea. It is a monolithic, invisible mountain with a small heyday of light at its summit. This revelation changed how we think about astronomic size. To be honest, when astronomers measure galaxy diameters, they typically measure visible light. But the true gravitational influence of a galaxy extends far beyond what telescope can see. Most extensive galaxies probably have darkness thing halos similar in proportion to ours, making them all much larger than their luminous disks suggest. Yet even with this extended halo, the Milky Way remains tiny compared to the following construction up the hierarchy. Our galaxy belongs to a radical, and that group clusters with other groups, forming something far more immense. To appreciate scale, we demand to soar out and see what our galactic island connects to. Andromeda sit 2.5 trillion light-year age away. close enough that you can see it with your naked eyes on a dark. That faint smudge of light in the configuration Andromeda stand for the most distant object without a telescope. But what you see isn't an ace or a cloud. You are looking at a galaxy containing over 1 trillion stars. And every photon reach your eye has traveled 2.5 million ELD to get there. The thing is, Andromeda is big than the Milky Way. Generally, measurements confirm its seeable platter spans just about 220,000 visible radiation age from edge to edge, more than double our galaxy's diameter. It comprised nearly twice as many stars as the Milky Way, and its mass likely exceed ours by a like factor. Pyrrhus Japonica is the dominant coltsfoot in our local neighborhood, and we orbit around a common heart of sobriety with it. The galaxy structure resembles ours in some ways. It is a spiral galaxy with a central hump and blazon wrapping around the core. Without question, a super inkiness hole sit at its ticker weighing 41,000 times what our Maven weigh. But Andromeda shows sign of violence in its past. Astronomers have detected unusual patterns in its stellar disk. Surprisingly, evidence that it consumed various smaller galaxies within the last few million years. Andromeda, still. Actually, it rushes toward the whitish way at roughly 250,000 miles per hour. Truth is, in about 4 billion years, confirmed through measurements of its motion, the two galaxies will clash. Generally, this won't be a pacify uniting. The collision will take hundreds of millions of years, with both galaxies passing through each other, their soberness pulling stars into long tidal tails. Finally, the two will unite into a single Titan elliptic galaxy. Someone's stars rarely collide during astronomic unify, because infinite between stars is so immense. Honestly, but the gravitational bedlam will fling some stars out into intergalactic space, while draw others toward the new galactic center. Our solar scheme might end up farther from the core than we are now. Plus, it could be excluded entirely. Simulations suggest we have a small chance of being thrown out of the merged galaxy altogether, left to drift alone through the cosmic void. By the time the merger completes, neither the Milky Way nor Andromeda will exist as separate entities. Truth is, a new galaxy, sometimes called Milkoma, will take their spot. It will be larger, more massive, and filled with new ice formed from gas clouds compressed during the collision. This is how galaxies grow, by devour smaller neighbors and merging with equals. On top of that, but Andromeda and the Milky Way aren't alone. Plus, they belong to a collection of close to 50 galaxies, all boundary together by gravity, all orbiting around their common middle of flock. The reality is, this structure, confirmed through extensive observations, forms what stargazers call the topical anesthetic grouping. The local group spans more or less 10 million years across. The Milky Way and Andromeda dominate, with the triangulum coltsfoot coming in third. The remaining members are midget galaxy, most contain fewer than a billion stars. And here's the thing, these small galaxies domain, the two giant ilk moons about satellite, trapped by soberness and slowly being pulled toward eventual collisions. Every galaxy in the local group shares a common fate. Gravity binds them together. And while the world expands, carrying distant galaxies away, the local grouping stiff intact. Often, the infinite between its member doesn't expand, because their mutual gravity is strong than the force of cosmic expansion. The truth is, we are locked together, and in the deep futurity, we will merge into a single monolithic galaxy, surrounded by darkness. But the local radical itself isn't alone. Notably, it belongs to a much big structure, generally one that makes even Japanese Andromeda look small. Surprisingly, 50 galaxies orbit through a volume of infinite roughly 10 trillion light-year across. And here's the thing. Honestly, this is the local grouping confirmed through decennium of careful observation and distance measuring. The truth is, every galaxy within this boundary is gravitationally boundary to the others, forming a stall scheme that resists the expansion of the universe. The Milky Way anchor one end of the topical anesthetic radical. Andromeda anchors the other. Between them lies the Triangulum Galaxy, the third largest member, spanning roughly 60,000 light-years and containing perhaps 40 billion stars. Look, these three spiral galaxies dominate the group's mass, but smaller companions. Actually outnumbered they at least 47 dwarf galaxy orbit within the local group. Most are orbiter of either the Milky Way or lily of the valley tree. As fuzzy patches of visible radiation, the substantial and small melanic cloud orbit our galaxy, visible from the southern hemisphere. Their being slow snap obscure by tidal forces. Their gas, an ace stretched into stream that feed the whitish way. Usually, lily of the valley tree has even more satellite. Importantly, over a dozen known Nanus galaxies circle it, and astronomers suspect many more rest undiscovered. Actually, these tiny galaxies are incredibly difficult to detect because they bear few stars and breathe little light source. Only pass-on surveys with sensitive instruments can spot them against the ground glow of remote galaxy. Of course, the local anesthetic group did not form all at once. Computer simulations reveal that small galaxies organize first shortly after the Big Bang. Over billions of years, they merged into larger structures. Definitely the Milky Way and Andromeda each grew by consuming dozens or century of small galaxies. The dwarf galaxies we see today are small enough to hold out merging so far. What's more, most will eventually be absorbed. Gravity clutch the local radical together, and that gravity is dominated by wickedness matter. The visible ace in all 50 galaxies contribute only a fraction of the total mass. Truth is, most of the group's mass invisible, spread end to end the volume in a web of dark thing that keeps everything bound. Without wickedness topic, the topical anesthetic grouping would have dispersed long ago, its member fling apart by the expansion of infinite. The center of batch for the local group sits somewhere between the Milky Way and Panane's Andromeda. Both galaxy domain about this point, which is why they're moving toward each other. Importantly, they're not falling into each other randomly. Without question, they're following gravitational orbits that will finally bring them together. The collision isn't a question of if, but when. Indeed, as the universe continues expanding, the space between galaxy groups turn. The local group will get increasingly insulate from other groups. Generally already, the nearest sit millions years away. The MAF radical lie around 10 million light-year distant, heavily obscured by rubble in the plane of the Milky Way. The sculptor group sits 11 billion light-years away. Clearly, these neighboring groups are receding from us. As space spread out, finally the local anesthetic group will unite into a one galaxy. Simulations suggest that in 100 billion in the age, Milky Way, Japanese Andromeda, Triangulum, and most known member will have combined. From the outside, observers would see one giant elliptic coltsfoot where three spirals once exist. From the interior, future inhabitants might aspect out and see nearly nothing. The nearest galaxies will have receded beyond the cosmic horizon. The reality is, but for now, the local anesthetic group remains part of a larger structure. The thing is, we sit near the edge of a vast assemblage of galaxy groups and bunch. And tremendous flattened disk of galaxy that makes the local anesthetic group look like a single grain of sand on a beach. Naturally, this construction prevail our corner of the universe. The Milky Way and Andromeda are on a collision line, rushing toward each other at roughly 250,000 miles per hour. This speed was confirmed through precise measurements of Andromeda's motion across the sky and its approach redshift. The impact will occur in approximate 4 trillion in age, give or takings a few century million old age depending on the exact trajectories. Imagine watching this hit from exterior galaxies. At the end of the day, at number 1, Kind of, the two spirals attack easy, their shapes still intact. As they draw a finisher, gravity begins pulling tidal tails from both. Indeed, long streams of stars reaching between them organize bridges of light crosswise the vacuum. The galaxies deform, their spiral blazon distorting as they feel each other's gravitative pull from millions of light years away. Then they, touching the leading edges of their dark affair halo, overlap. Stars from one galaxy pass through regions of the other. Somebody's stars almost near collide. Space between stars is so vast that collisions are statistically unlikely, even during astronomic merger. What does clash is gas? Enormous clouds of hydrogen slam into each other at incredible speed, compressing and heating. The compression triggers wave of star formation, lighting up both galaxies with brilliant new stars. The number one pass take million of ELD. Definitely, the galaxy interpenetrate, their centers passing within tens of 1,000 of light years of each other. Usually, gravity twists both construction, pulling stars into new orbits. Some ACE gain enough velocity to escape both galaxies entirely, flung out into intergalactic infinite to wander lone eternally. Others fall toward the center, where the two supermassive inkiness holes begin their own deadly dance. Indeed, the galaxies separate after the number one pass, fundamentally, but they don't flight. Sobriety pulls them back. Over the following few 100 million-old age, they really swing about their common center of mass and collide again. Each collision strips away more stars, create enormous tidal tailcoat stretch for century of chiliad of visible radiation ELD. These tailcoat mark where stars have been pulled from their home galaxy and left wings stranded in the space between. After multiple passes, the galaxy lose their spiral structures, the organized rotation that maintain their arms good luck down. Stars begin revolve randomly, creating a, essentially, global cloud rather a platter. This is how elliptical galaxies form. Here's the bottom line. They're the merchandise of major merges. Their chaotic stellar orbits evidence of violent pass. Ultimately, the two galactic cores unify. Indeed, the crack-massive black hole at each center sink toward each other, forced by gravity and dynamic friction. Really, when they come finis enough, they begin orbiting each other, spin around faster as they lose energy to gravitational wave. Surprisingly, corroborate by recent detections of gravitative waves from merging inkiness holes. We know this process happens though we have never observed super-monolithic inkiness holes conflude directly. The black holes helix inward for millions of ELD. Then in the final exam moments they unify in a cataclysm that releases more zip in gravitational waves than all the stars in the galaxy breathe light. Frankly, the merged black hole weighing hundreds of millions of times what our ACE count sits at the heart of the new elliptical galaxy. Our solar scheme will likely survive. The chances of a AIM stellar collision are bantam, but our place within the Coltsfoot will alteration. We might end up farther from the center, or we might be forced inward. There's even a small chance we get ejected entirely, thrown out into intergalactic infinite during one of the disorderly passes. Often by the time the merger finishes, the night sky will aspect completely various. Pieris Japonica will no longer be a distant daub. During the height of the collision, it will dominate the sky, stretching across dozens of degrees. As the two galaxies intertwine, new adept will blaze to life in monolithic adept-forming regions. The thing is, and then tardily the chaos will settle into a new stable configuration. Usually, the event will be an oval-shaped Coltsfoot, sometimes called Milkda. The reality is, basically, it will contain all the stars from both the Milky Way and Andromeda, well over 1 zillion stars in total. Indeed, but even this giant will be just one Coltsfoot among many. Think about it this way, and it will belong to a construction far bigger than itself. Without question, 74 billion light in direction of the constellation Virgo lies a massive concentration of galaxies. Importantly, The Virgin Cluster contains over 2,000 galaxies packed into a region about 15 million light-year crosswise. Giant oval-shaped galaxies predominate its core. The large being Messier Secchi, a monster galaxy with a super-monolithic inkiness hole, weighing 6.5 billion times what our star weighs. The Virgin Cluster isn't insolent. Look, surrounding it, spreading across a huge flattened disk, sit at least 100 other galaxy group and clusters. The reality is, definitely, this entire structure forms the Virgo supercluster, sometimes called the topical anesthetic supercluster, because the local group sits near its border. The supercluster spans roughly 110 billion light-years from side to side, confirmed through extensive mapping of galaxy positions and velocity. Let me put it this way. Our local radical occupy a position far from the center, about 65 trillion light-year from the Virgo cluster. Let me put it this way. We sit on the outskirts of this construction near the edge of the disk. Often from our vantage point, the Virgo cluster's gravity tugs on us, pulling the local group toward it at a few century ms. This motion is called the Virgocentric flowing, and it has been confirmed through precise mensuration of galaxy velocities. The Virgo supercluster isn't spherical. So, what does this mean? A kind of flattened ellipsoid, like a platter or pancake. The galaxies concentrate along this platter, with relatively few galaxies in the regions above and below. This flattened form results from how the structure formed. Dark matter collapsed first, creating a scaffolding, and galaxy formed where wickedness matter was densest. Between the concentration of galaxy lie void. These are vast area of nearly empty infinite, sometimes 10 of millions of lights-old age across, comprise very few galaxies. The voids and fibril together generate what astronomers call the cosmic web, galaxy cluster along the filaments, which lineation the surfaces of tremendous bubbles. The nullity are the interiors of these bubbles, largely empty. Usually, the Virgo supercluster contains about the DL equivalent weight of 100 billion whitish-way galaxy. Think about it this way. This includes both visible matter and darkness affair. What's more, most of that deal is dark affair spread throughout the mass in a halo that extends beyond the visible galaxies. Clearly, the lambda matter, all the stars and gas we can see, represents only a 15% of the total deal. Obviously, contempt its enormous size. The Virgo supercluster isn't gravitationally edge as a one structure. The expansion of the existence is pull its outer regions apart. Only the dense concentrations, like the Virgo cluster itself, are covenant enough to defy expansion. And here's the thing. The residue of the supercluster will slowly disperse over billion of years as space expand between Coltsfoot groups. Clearly, this was a surprising uncovering made in Holocene decades. Usually stargazer once thinking superclusters were gravitationally bound objects like scaled-up versions of galaxy clusters. But detailed measurements revealed otherwise. The Virgo supercluster isn't a stable construction. The thing is, it is an impermanent concentration of galaxy that happens to exist in our current era. In the trench future, it will no longer be recognizable as a distinct entity. But here's what's interesting. Yet, even this impermanent structure is simply one thread in a larger tapestry. Now, here it gets good. Recent observations unveil that the Virgo supercluster is part of an even more immense concentration of galaxies, one that makes the supercluster look small. Look, the Virgin supercluster contains a mass equivalent to 100 billion Milky Way galaxies. Let that number settle. 100 trillion copy of our entire galaxy. All the ice and gas and dark matter compressed into a single structure in 10 light-years crosswise. But the Milky Way itself comprise up to 400 trillion adept, manifold 100 billion galaxy by 400 billion stars each, and you get a number so large it lose meaning. 40 sextillion stars spring, or issue. But here's what's interesting. That's 40 followed by 21 zeros. really more stars in the Virgo supercluster than grain of sand on every beach across continent. Yet, this number mostly comes from theoretical computing, not place observation. Astronomers cannot count every maven in the supercluster. Also, most are too distant and faint. Instead, they measure the total batch by discover how galaxy relocation. The velocities of galaxies within the supercluster reveal the gravitative forces playing on them. More mass means stronger gravity, which agency higher velocity. Obviously, by mapping these motions, the flock of our star. This central concentration pulls on surround galaxy group, creating the Virgo-centric flow, the local radical, toward the clump at hundreds of miles s. If we could see darkness matter, the supercluster would look ilk a vast web of interconnected filaments. Frankly, galaxies would appear as vivid nodes, where filaments intersect with tendrils of dark matter stretching between them. The nullity would be seeable as tremendous bubbles, their surface traced by galaxy-filled filaments. But the Virgo supercluster isn't the end of the power structure. It exists as portion of an even big structure, in reality, one that midget everything we have discussed so far. Certainly, in 2014, a team of astronomers announced an uncovering that redefined our cosmic reference. At the end of the day, really, using a new proficiency to map Coltsfoot flowing, they unveil that the Virgin supercluster is just one lobe of a much greater concentration. This larger construction contains more or less 100,000 galaxies, include the Milky Way, Pieris Japonica, and the entire Virgo supercluster. Indeed, it spans 520 million light-years from end to end, making it one of the largest structure in the known world. The mass is equivalent to 100, fundamentally Milky Way galaxy, though estimate vary. The discovery came from mapping not where galaxies are located, but where they're locomote. Galaxies don't move arbitrarily through space. They spill toward concentration of batch along paths ascertained by gravity. By tracing these paths backward, uranologists identified the gravitative actually basin that holds our local region of the world together. This immense structure has a center, a gravitational focal point toward which everything nearby is fall. The Virgo cluster is falling toward it. The local grouping is falling toward it. Chiliad of Coltsfoot groups and clusters crossways 1c of millions of light years are all being drawn in the same direction. That gravitative center has a name, and it represents one of the great mysteries in Bodoni astronomy. Surprisingly, something massive is pulling our galaxy. The Milky Way, the local group, the full Virgo supercluster, all moving in the same way at over 1 million amps/year. Stargazer call the terminus the Great Attractor. And for decades, it stay on one of the most puzzling anomalies in cosmogony. The evidence for this movement came from observation of the cosmic microwave oven background, the faint radiation left over from the Big Bang. On top of that, this radiation should seem uniform in all directions if we were at balance relative to the cosmos. But measurements unveil a dipole form, the radiation slightly hotter in one direction and cooler in the antonym direction. This pattern indicates motion. We are moved through space, and the motion creates a Doppler shift in the background radiation. Often, astronomers calculated our speed and direction. The entire local supercluster is descend toward a region of infinite, about 250 trillion light-year-old age away, in the way of the constellations Hydra and Centaurus. The batch required to create this gravitative pulling must be tremendous, combining weight to decade of 1,000 of Milky Way galaxies, concentrated in one region. But looking in that direction revealed a problem. No doubt, the plane of the Milky Way obscures the view. Dust and stars in our own galaxy block optical light from that part of space, create what stargazers call the zone of avoidance. Early attempts to observe the Great Attractor directly saw very little. What's more, a few galaxy clusters were detected, but not enough deal to explicate the detect movement. Radio and X-ray observation eventually penetrated the dust. They revealed various monolithic galaxy clusters in the area, including the Norma bunch and the Centaurus clustering. Together, these clusters comprise enough mass to chronicle for some of the gravitational pull. Additionally, not all of it. The Great Drawing Card appear to be more diffuse than a simple cluster spread across a large volume of infinite. The mystery deepened when astronomers realized the motion doesn't stop at the Great Attractor. The Great Attraction itself is moving, pulled by an even larger concentration of mass farther away. This second construction, called the Shapley Supercluster, sits 6.6 quite trillion light-year remote and contains over 8,000 galaxies. It is one of the most massive structures in the observable world, and its gravity influences galaxy motions crossways tremendous distance. The discovery of these massive structures led to a broader understanding. Galaxies don't move arbitrarily through the universe. Think about it this way: they flow along paths determined by the distribution of matter, both visible and dark. These flows converge toward high-density regions and diverge from low-density void. By mapping the flows, astronomers can reconstruct the underlying mass dispersion, even where direct observance are unmanageable. In 2014, this technique uncovered that the Great Drawing Card isn't a single isolated mass concentration. It is the core region of an enormous structure comprised the Virgin Supercluster, basically, the Hydrocentrus part, and various other superclusters. This greater structure has been confirmed through multiple freelance analyses of galaxy velocities and positions. The thing is, the Great Attractor region marks the gravitational center of this vast basin. Everything within 520 million light-year falls toward it, pulled by the unite gravity of all the topic within the structure. The Virgo supercluster, which once seemed like the dominant feature in our area of the universe, is merely one portion of this big whole. On top of that, this discovery forced a re-evaluation of what constitutes a distinct structure. The Virgo supercluster isn't gravitationally, sort of, bound and will finally disperse. But the big structure of which it is a portion may represent a true dynamic scheme, at least temporarily. That larger structure has a name given to it by the astronomers who mapped its extent. They called it Laniakea. The name comes from Hawaiian immense heaven or open skies. Laniakea Supercluster, confirmed in 2014 through full mapping of galaxy velocity, spanned 500 million light-year age from end to end. Sometimes, it contains approximately 100,000 galaxies, include our own, all move in coordinated flows toward a common gravitative center. This is our cosmic address on the largest scales currently mapped. Earth sits inside the solar scheme, which orbit within the Milky Way, which belongs to the local anesthetic radical, which lie close the edge of the Virgo supercluster, which is one lobe of Laniakea. Each level of this pecking order increases in size by factors of millions or billion. Laniakea isn't a single compact object. Look, it is a sprawling web of interconnected filaments and nodes, concentrated along threads that outline enormous voids. The structure resembles a biological scheme, arteries of galaxies feeding into larger concentrations. The Virgo supercluster forms one major branch. The Hydrocentrus region kind some other. Importantly, several other superclusters contribute additional deal. The truth is, the total mass of Laniakea equals approximately 100 quadrillion multiplication the batch of our ACE. That number 1 followed by 17 zeros represents the combined mass of all quite galaxies, all gas, and all darkness matter within the construction. Dark matter contributes the huge majority, forming an invisible scaffold that holds everything together. Generally, galaxies inside Lania move in coherent shape. Instead of expand away from each other uniformly, they along preferred direction, converging toward the dense regions. These flowing hint the underlay dark matter distribution. Where dark matter is concentrated, galaxies spill inbound. Where dark matter is sparse, galaxies drift outward into nihility. The boundary of Lania isn't a physical edge. It is defined by the limit of the gravitative basin. Beyond this bound, galaxies flow toward other attractors, other gravitational centers. The adjacent basin belongs to another supercluster, the Perseus-Pisces Supercluster, which pull on galaxy in its own region. In fact, between these basinful at the water's boundary, galaxy motions become ambiguous. Laniakea itself isn't gravitationally edge. Detailed analysis displays that the enlargement of the universe is pull its outer part isolated fast than gravity can hold them. Really, the construction will disperse over billions of years. Only the dense nucleus, like the Great Attractor region, might remain bound. The rest will be carried away by cosmic expansion. The thing is, this raises an inquiry about whether Lania should be called a supercluster at all. Traditional definitions require construction to be gravitationally boundary. So, what does this mean? Lania doesn't meet this criterion. As an impermanent concentration of galaxies that share a common gesture form in the current epoch, it is more accurately described. Sometimes, hereafter cosmologists may see the galaxy now in Lania scattered crosswise much larger distances. Here's why this matters. Yet disdain its transit nature. Lania represents our place in the existence on scales approach the limits of what we can currently map. Beyond Lania lie other structures, other basins, really of galaxies flowing toward their own center. The universe at the large scales resembles an sea with countless currents and eddies, each containing billions of galaxies. The uncovering of Laniakea changed how astronomers think about cosmic structure. Instead of defining structures by their appearance, we now specify them by their dynamics. Importantly, a supercluster isn't just a group of galaxy clump that happen to be near each other. It is a region of infinite, where galaxies share a park gravitational influence. This dynamic view reveals patterns invisible to traditional surveys. Honestly, the cosmic web becomes open when you map galaxy velocity. Obviously, filaments appear where a fair flows along heavy thread, but here's what's interesting. Voids emerge, where galaxies quicken away from under heavy regions. And at the intersections of filaments, massive concentrations of galaxies form the nodes that anchor the web. But even the cosmic web, spanning billions of light years, represents only what we can observe. The existent universe extends beyond our seen, maybe endlessly, and its structure proceeds beyond Lania, forming patterns we are only beginning to comprehend. The universe isn't random. Galaxies don't scatter evenly through space. Instead, they arrange themselves in an elaborate network of filament and sheets separated by vast nihility. This pattern, confirmed through decades of galaxy survey, is named the cosmic web, and it stands for the largest scale of measurement structure in the existence. The cosmic web formed from petite density fluctuations in the early universe. Shortly after the Big Smash, matter was distributed almost uniformly, with only minuscule variations in density from property to place. These variations, sustained by observations of the cosmic microwave oven background, served as seeds for construction formation. Soberness amplified the variation. Regions slightly denser than average pull in more matter, becoming denser still. Regions slightly less dense, doomed topic to their environment, becoming voids. Over billions of years, this process created a hierarchy of structures. Small bunch merged into larger ace. Galaxy organize where dark matter accumulated. In fact, those galaxies gathered into groups, then cluster, then superclusters, all following the underlying dark thing dispersion. The outcome is a web of filaments. Let me put it this way. These cosmic threads span hundreds of thousands of light years in length, but they're only a few million light years thick. Really, galaxies concentrate along the filaments like beads on a string. Where multiple filaments intersect, massive galaxy clusters form. Clearly, these clusters can contain thousands of galaxies in regions tens of millions of visible radiation years crosswise. Between the filaments lie the nihility. What we're seeing is, these are tremendous bubble of nearly empty infinite, typically 50 to 100 million light-year in diameter. Some voids range 300 million light-years crosswise. They contain very few galaxies, and those that live tend to be small nannies. The voids aren't completely empty, as they hold some dark matter and gas, but their density is far below the cosmic average. The cosmic web isn't atmospheric static. It evolves as the universe expands. Filaments stretch and thin. Voids grow larger. Galaxy within strand gradually fall toward the nearest bunch, pulled by gravity. Over time, the direct contrast between dense and empty regions increases. While the poor get poorer about mass distribution, the rich get richer. Simulation reproduce this construction remarkably well. Computer models, with iniquity matter particles distributed according to the denseness fluctuation observed in the cosmic microwave ground. Let me put it this way. They evolve the particles forward in clip using gravitational physics. The result Lucifer, what surveys observe. Strand form, voids appear, clump develop at the nodes. The cosmic web emerges, of course, from graveness, acting on slightly uneven initial conditions. Observations sustain the simulations. Large-scale surveys like the Sloan Digital Sky Survey map millions of galaxies crossways a significant fraction of the sky. The data unveil the cosmic web in exquisite detail. Filaments and voids became visible. Superclusters appeared as concentrations along the filaments. The universe showed open construction on scale approaching 1 trillion light-years. The thing is, the cosmic web is shaped by wickedness topic. Luminous matter, the stars and gas we can see, follows where dark affair leads. Dark matter filaments formed number 1. Galaxies assembled inside them late. This is why the dispersion of galaxies hint the cosmic web. Of course, they're merely marking where wickedness matter is concentrated. Interestingly, but the web itself rests on an even larger practice. The filaments aren't space. Usually, they have characteristic lengths and spacings. This scale, roughly 300 million light-year, represents the typical size of structures that formed from the primordial density fluctuations. Littler fluctuations make smaller structures. Large fluctuations created larger one. The prime in the fluctuation power spectrum corresponds to structures about this size. The cosmic web extends throughout the observable universe. Every way we look, we see the same pattern: filament and nihility, clusters and superclusters. The structure is universal. Let me put it this way. This uniformity tells us that the physical process create the web operated the same way everywhere, reinforcing the cosmological rule that the universe is homogeneous on the largest scales. Yet between the strand, in the vast voids, lies something that challenge our apprehension of structure. These empty regions are larger than anything else in the world. The Botus void stretches 330 million light-year across. Inside this enormous bubble of space, stargazer have launched only about 60 galaxies. A distinctive region of that size, you'd find about 10,000 galaxies. The vacuum is 99% empty compared to the cosmic average. Voids dominate the bulk of the world. While strand and cluster contain most of the galaxies, they occupy a relatively small fraction of total space. Voids, by contrast, fill most of the universe's volume. If you picked a random point in space, you'd most likely find yourself interior vacancy, hundreds of millions of visible light years from the Nye galaxy cluster. The best nullity isn't alone. Have revealed tons similar. Actually, the Carver void spans similar distance. The Eridanus supervoid measures nearly 1 trillion light-year crossways, one of the largest cognized structures of any kind. These voids aren't perfectly empty. They contain some darkness, thing and gas, and a handful of isolate. Sort of galaxy float in their interiors, but their denseness is far below average. How do nihility develop? They result from the same process that create filaments and bunch, just in reverse. Regions that started slightly under-dense after the, pretty much, Big Bang lose matter to their surroundings. Look, as denser regions pulled in material, the underdense region become more depleted. Graveness emptied them out over billions of years. The operation is confirmed through simulations which display voids naturally emerging from the gravitational evolution of matter. Indeed, interior nullity, the expansion of the existence proceeds somewhat fast than average with less mass to slow it down. Space expands more freely. This creates an outflow practice. Galaxy close the edges, accelerate away from the centers. Overclip. This pushes the few remaining galaxy toward the void boundaries, making the interior emptier. Plus, the galaxies that do survive inside voids tend to be different from those in dense area. They're often younger with more active star shaping. This makes sense. In clusters, galaxies clash and unify frequently, using up their gas supplies and quenching maven formation. Inside voids, galaxies remain insulate. They keep on their gas thirster and proceed forming ice at a steady pace. Surprisingly, voids also affect the cosmic microwave ground. Indeed, light from the early creation passes through nullity on its way to us. Truth is, as photons into a void, they profit energy. As they climb back out, they lose energy. Obviously, if the void size did not alteration, these effects would cancel. Generally, but because the world expands, voids grow during the photon's transit. In fact, the photon loses more energy climbing out than it gained falling in. This creates a low-temperature spot in the cosmic microwave oven background, a shadow of the nullity. Generally, one such cold spot exists in the way of the Eridanus supervoid. Observations confirm that the temperature in that region is slightly lower than the surrounding background. The deficit matches what we ask if a supervoid lie along the line of sight. This provides independent evidence for the void's existence beyond just the loose galaxy. Nullity challenge some cosmological models. The largest go up the limits of what standard theories predict. If structures too major compare to what initial conditions let form, it suggests something unexpected go on during the universe's early evolution. Plus, most voids fit within predictions, but the biggest one pushed the boundaries. On top of that, the existence of nihility also creates a philosophic query. If most of the volume is nearly empty, what does it mean to say the universe is make full with topic? Thing dressed or in bantam threads and knob, like foam on an ocean surface. The bulk of infinite contain almost nothing. We inhabit in one of the rare thick regions on a satellite in a galaxy in a filament. Most of the cosmos is silence and darkness. Here's the bottom line. Yet even the largest voids are tiny compared to the observable creation. And the nullity thems are part of a structure that spans farther than we can yet realize. Notably, the cosmic web widened to the limits of observations. Plus, and beyond it lies more web, more structure. Truth is, continuing outward past the cosmic horizon. But discernment how all this structure clenched together requires understanding the invisible scaffolding beneath it. 85% of the matter in the universe is invisible. It doesn't breathe visible radiation. It doesn't absorb light. It doesn't interact with electromagnetic in any way we can detect. Often, it prevail the universe's mass budget, and without it, nothing we see could survive. Stargazers call it darkness matter, and its existence is confirmed through multiple freelance observations. The evidence began with galaxy rotation curve. Stars at the edge of helix galaxy orbit, then they should if only visible thing existed. The truth is, consort to Newton's law, objective further from a flock center should orbit more slowly. And here's the thing is, adept at the outer edges of galaxies maintain high velocities. This implies that additional unseen mass extends far beyond the, pretty much, seeable disk property those stars in their fast domain. Coltsfoot clusters provided more grounds. The velocities of galaxy within clump are too high for the seeable topic to hold them together. Clusters should fly apart unless additional flock supply extra soberness. Observations of hot gas in clusters corroborate this. Interestingly, the gas temperature and distribution need far more mass than we see in adept and gas-lonely. Gravitational lensing sealed the case. Light from distant galaxy bends as it passes through monumental structures. The amount of bending depends on the total flock along the line of sight, regardless of whether that batch emits light. In fact, observations show that galaxy clusters bend light source far more than their seeable topic alone could explain. The lensing maps unveil dark matter, or a surrounding and permeating the clusters. Really, dark matter kind the scaffold of the cosmic web. Clearly, computer simulations that include only dark matter produce structure outstandingly similar to what we detect. The simulations start with tiny denseness fluctuations. Dark thing molecule collapse into strand and nodes under gravity. Where wickedness matter concentrates, it creates potential wells. Normal matter falls into these wells and forms galaxies. The visible world traces the invisible dark matter dispersion. What's dark affair made of? We don't know. Interestingly, it must be something that interacts gravitationally but not electromagnetically. Particles this don't exist in the criterion model of spec physics, which way wickedness matter is probable something new, something not yet discovered in laboratory experiments. Candidates include weakly interacting massive particles, axons, or perhaps primordial inkiness holes. Experiment about the world search for target detection, but so far dark matter remains elusive. Despite not know its composition, we can map where darkness matter is turn up. Plus, gravitational lensing creates detailed map of dark matter dispersion in Coltsfoot cluster. Definitely, these maps display darkness matter concentrated in the same part as galaxies, but extending farther. Dark affair or about clusters span tens of millions of light age, essentially, far larger than the seeable galaxy dispersion. On larger scales, dark topic defines the cosmic web. The reality, fibril are primarily dark thing, with galaxy marking their locations. Voids are regions where darkness matter is sparse. The structure of the existence at the largest scale is the structure of dark matter dispersion. Visible matter is just a tracer, a small component following the dominant unseeable batch. Notably, dark vigor isn't the same as dark matter. Indeed, dark vigor is even more cryptical. It is a property of space itself, causing the enlargement of the universe to quicken. Darkness energy pushes them apart, while dark matter provides gravity that pulls structures together. Think about it this way. Dark topic kind structure. Dark energy disrupts it. The balance between these two invisible components determines the fate of the existence. Stream measurements betoken that dark energy makes up 60% of the universe's total energy density. Dark matter contributes about 27%. Rule matter, everything we can see and touching, amounts to only 5%. Notably, the universe consists mostly of things we don't comprehend. The thing is, this invisible architecture extends throughout the observable universe. Wickedness matter filaments connect all structures. Dark vigor fills all infinite. Of course, together they shape the cosmos on scales from individual galaxies to the largest superclusters. Everything we detect is a aftermath of their influence. No doubt. Yet Eve with iniquity matter and dark energy dominating. Visible structures survive that nan is the whitish way by factors that seem impossible. Usually, C1101 sits over 1 billion light-years away. Obviously, so remote that its light has traveled for more than 1 zillion age to reach us. Importantly, it is the largest cognized galaxy, basically, a supergiant elliptical, that span approximately 4 trillion light-year from edge to border. That makes it 40 times wider than the Milky Way's visible record, and twice as wide even include our witnessing halo. This galaxy contains over 100 trillion stars. That figure, 100 followed by 12 zeros, represents more than 200 multiplication the Milky Way's star population. If every star in IC 1111 had a planet and every planet had a moon, the total figure of worlds would still exceed inclusion. The Coltsfoot's mass equals approximately 100 trillion times the mass of our Adept, devising it one of the most monolithic single galaxies known. IC-1001 did not form in isolation. Frankly, it grew by consuming other galaxies over millions of years. Elliptical galaxies like this one are our idea to be the products of major mergers. When two spiral galaxies collide, their organized rotation breaks down, the merger scrambles prima orbits, creating a global cloud instead of a disk. Repeated merges build batch, and IC1 has likely undergone countless such collisions. The galaxy's central contains a supermassive black hole weighing approximately 66 billion times what our Adept consider. This is one of the most massive inkiness hole ever measured. By comparison, the inkiness hole at the Milky Way, sort of, heart only 4 million times our star's deal. IC 1100, and one's inkiness hole, is 16,000 multiplication more monumental. Its gravitational extends across thousands of light-years, dominating the galaxy's essential part. IC-151 sits on the center of the Able 289 Coltsfoot cluster, one of the richest clump in the observable world. Its position at the cluster's core isn't coincidental. Let me put it this way, because they sink to the bottom of the gravitational well through a process called dynamical clash. The most monolithic galaxies tend to lodge in cluster center. Indeed, as IC-1011 move through the cluster, it interact gravitationally with surround galaxies, losing orbital energy and settling toward the center. From IC-101, the night sky would look unusual. The Coltsfoot's outer regions are thin with stars separate by vast distances. Here's why this matters. Of course, an observer in those outer reach might see a sky darker than ours, with only distant point of visible radiation from neighboring galaxies. But toward the center, the sky would blazing. Stars packed densely in the fundamental create a diffuse glow vivid enough to cast shadows Eve from light old age away. IC-111 stand for an extreme, but it isn't. Without question, other supergiant ellipticals exist end to end the universe. Let me put it this way. To be honest, Messier 87 in the Virgo bunch, though smaller than IC1, Sentinel 1, still dwarfs the Milky Way. These monsters reside at the centers of massive bunch, grown fat on the galaxies they have consumed. The existence of such substantial galaxy tells us about structure shaping in the universe. Surprisingly, galaxies grow through unite and accretion. Small galaxies formed first shortly after the Big Smash. Honestly, over a million of old age, essentially, they merged into larger ones. The procedure go along today. IE-11111 is hush growing, slowly consuming dwarf galaxy that roll too close. Here's why this matters besides, but most galaxies aren't behemoth like IC-101. Notably, for every Crichton elliptical, billion of dwarf galaxies subsist. Frankly, too small and swoon for most surveys to observe. These tiny galaxies vastly outnumber the behemoth, and they reveal a different side of the cosmic hierarchy. Most galaxies in the universe contain, pretty much, fewer than 1 billion stars. These dwarf galaxies outnumber giant like the Milky Way by factors of century or thousands to one. The small melanic cloud visible from Earth's southern hemisphere holds only a few billion stars and span just 7,000 light-year. Here's why this matters. Plus, yet even this relatively bright dwarf represent the upper end of the size range. The truth is, the faintest galaxies discovered contain only a few thousand adept sum, spread across regions a few hundred light-years broad. These ultra-faint dwarf emit so little light that they remained hidden until recent survey with pass-on telescope detected them. The Segi 1 midget galaxy orbit, the kind of Milky Way incorporate rough 1,000 stars. An observer interior would see a sparse scattering of points against the darkness, barely adequate to qualify as a galaxy at all. Dwarf galaxy present a puzzle. According to cosmological simulations, far more small iniquity, sort of, matter halos should exist than we find dwarf galaxies. Think about it this way. The framework predict thousands of small halos around large galaxies like ours. Yet we find only heaps of dwarfs. This disagreement is called the missing satellites problem, and it suggests either our models are incomplete or most dwarf galaxies are too syncope to find. Recent surveys support the second explanation. Advanced telescopes support discovering new ultra-syncope dwarfs around the Milky Way and Andromeda. Each survey that pushes to faint limits finds more. The evidence suggests that thousands of dwarf galaxies orbit nearby, most unseeable to current instruments. When the next generation of telescopes comes online, the sensely explode. So what does this mean? Nomi galaxy have dominated cosmic chronicle concerning numbers. In the early universe, shortly after the first stars form, small galaxies appeared everywhere. These proto-galaxies contained only millions of stars each, but they were abundant. Over time, they merged into larger structures. Now, here's where it gets good. The dwarfs we see today are subsister, small enough to resist conflux so far, though most will finally be consumed. Really, dark matter dominates midget galaxies more than it dominates large ones. Actually, some ultra-faint dwarfs have deal to visible light ratios exceeding 1,000, substance than 1,000 times more deal in dark matter than in ACE. They're essentially mist aura, with a tiny sprinkling of ACE. Without dark matter, these galaxies would not have enough gravity to clasp together. Star would escape into intergalactic infinite. Also, GNOME galaxies reveal the get-down limit of galaxy formation. Below a sure dark thing halo mass, galaxies cannot create at all. The smallest halos lack sufficient gravity to pull in and retain gas. Starlight and cosmic radiation heat the gas, preventing it from chilling and collapsing into ACE. Only halos above a threshold mass can overcome these effects and form visible galaxies. Think about it this way. This threshold explains why we don't see galaxies little than the ultra-faint dwarfs. To be honest, the physics of gas cooling and maven shaping sets a lower limit scale. Below that graduated table, dark matter aura survive but remain iniquity, devoid of stars. These invisible halos populate the universe, detectable only through their gravitative effects on visible topic. The compound mass of all dwarf galaxy probable subs that of behemoth galaxies. Interestingly, they're individually tiny but collectively numerous. It might rival or exceed the mass in major galaxy like ours. If you sum the total stellar mass in all dwarf end-to-end the evident universe, the universe's population is bottom-heavy, with most galaxies clustered at the small end of the size distribution. Yet, even as midget galaxies dominate the population count, they slicing into insignificance when facing the force that controls the destiny of the cosmos itself. The universe isn't just spread out, actually, it is accelerating. This uncovering confirmed in 1998 through observance of distant supernovae shocked cosmologists. Clearly, the expansion should be slowing down due to graviness pulling everything dorsum together. Instead, galaxies are flying apart fast and faster. What's more, The evidence come from Type Ia supernova exploding, basically white nanos stars that serve as cosmic distance markers. At the end of the day, definitely, these explosions range consistent peak brightnesses, allowing astronomers to calculate distances by measuring how bright they appear. Clearly, comparing distances with redshifts reveals the enlargement rate at separate cosmic era. Remote supernova appear fainter than expected. Sometimes, if the expansion charge per unit were invariable or decreasing, this means they're farther away than they should be. The only explanation is that the enlargement has accelerated since those supernova exploded billions of old age ago. Space itself is stretched faster now than it did in the past. This quickening requires something new, something that pushes space isolated instead of pulling it together. Cosmologists call it dark energy, and it makes up close to 68% of the universe's sum-vigor density. Unlike dark matter, which clumps and creates gravity, wickedness energy spreads uniformly through infinite and generates a repulsive force. Dark energy's nature cadaver mysterious. The simplest explanation is that it represents the zip of empty infinite itself, sometimes called vacuum energy or the cosmological constant. The reality is, quantum field possibility predicts the empty space should have zip. Though calculations yield values wildly alternative from what we observe, the discrepancy, named the cosmological invariable job, is one of the biggest unsolved puzzles in physics. Careless of its nature, dark zip's effects are clear. It makes the expansion speed up. At early times when the universe was littler and denser, iniquity vigor contributed small compared to affair. Gravity dominate, slowing the expansion. What we're seeing is sometimes, but as the universe grow and matter spread out, darkness vigor become increasingly important. About 5 billion eld ago, confirmed through multiple freelance measurements, dark vigor's repulsive effect exceeded soberness's attractive pull. The enlargement get down accelerate. Indeed, this acceleration has profound consequences for the universe's future. Structures that aren't gravitationally bound will be drawn apart. The truth is, galaxy clusters will remain inviolate because their internal gravity is strong enough to resist, but superclusters will disperse. The cosmic web will reaching until fibril snap. Without question, eventually, evening galaxy groups might be torn apart, leaving each galaxy isolated. What's more, the Milky Way and Japanida will hush clash, because they're gravitationally boundary and close adequate that iniquity energy cannot overpower their attraction. But more distant galaxies are already receding beyond our reach. Light they breathe today will never make it because infinite between us expand too fasting. They're crossing the cosmic horizon, disappearing from the observable universe eternally. In the far hereafter, perceiver in our merge galaxy will look out and see almost nothing. The nearest galaxy beyond our local kind of group will have red shifted into invisibility. Frankly, the cosmic microwave background will slicing to undetectable levels. Infinite will appear empty and black. Plus, future civilizations' power conclude they live lonely in a static, unchanging existence, incognizant of the billions of galaxies that once fill the sky. Iniquity energy, besides, affects the shape of space. Here's the deal. Measurements of the cosmic microwave background and galaxy distribution indicate the world is geometrically flat, or very nearly so. This flatness is maintained partly by wickedness energy's influence. Truth is, the creation might be curved in ways that would make large-scale structure shaping impossible. Dark vigor strength were different. The acceleration set an ultimate boundary on what we can observe. Even if we wait forever, there are galaxies we will near see. Their light will never scope us. They subsist beyond the cosmic horizon in regions, pretty much of space forever disconnected from our own. But this raises a query that has haunted astronomers since Edwin Hubble No. 1 measured the expansion. If galaxies beyond a certain distance are unapproachable, Essentially, what defines the edge of observation? 6 zillion light years. That distance marks the edge of the discernible universe in any direction from world. Usually beyond that limit, nothing can be discovered. Notably, light from farther apart has not had time to reach us since Big Knock, and due to quickening, it never will. Now here's where it gets good. This create a ball-shaped bound about us, basically sometimes called the particle horizon. Everything inside this sphere is potentially evident. Everything outside cadaver forever unseeable. The boundary isn't a physical wall. It is a consequence of the universe having a finite age and the finite speed of visible light. The cosmic skyline shift with time. As the universe ages, you cognize light from more distant regions reaches us for the first time. Every second, the observable universe grows. New galaxies look at the edge of visibleness. Their ancient light source ultimately, quite, completing its journey crosswise space. But this growth has a limit. Due to acceleration, there's a maximum distance light can air traveling to range us, no topic how long we wait. This defines a distinct horizon, sometimes named the cosmic case skyline. It sits at just about 62 billion light-year, confirmed through cosmological calculations. Galaxies currently beyond this distance are receding fast than light source can finish the gap. Their light will ne'er arrive. This create a strange asymmetry. Because we are observing light they emitted billions of years ago when they were closer, we can see galaxy now beyond the event horizon. But we will never see what they looking like today or what they become in the futurity. Those galaxies have crossed a boundary and entered a region of space causally disconnected from ours. From those remote galaxies' perspective, we have crossed their case horizon. Perceiver there can see our galaxy, as it appeared billion of eld ago. But they'll ne'er receive radiation showing what we get. We survive in each other's past times, but not each other's future. The expansion of space has severed the connection, to be honest. The purview create an isolation more absolute than mere distance. What does this mean? Even if we could traveling at the speed of visible radiation, we could ne'er reach galaxies beyond the case horizon. The space between us expand faster than we could cross it. Attempting the journey would be ilk running on a treadmill that accelerate fast than you can run. You'd never make progress toward your destination. This raises philosophical questions about the nature of existence. Do galaxies beyond our horizon subsist in any meaningful signified, if we can never interact with them or receive information from them? What we're seeing is, natural philosophy propose they do. At the end of the day, usually, the laws of nature don't change at the purview. Now here's where it gets good, space go along beyond it. But we can ne'er verify this through observation. The horizon also affects our ability to understand cosmology. We sampling only a finite region of space. The observable existence power not be representative of the whole. If the world is infinite, fundamentally, we see an infinite decimally small fraction. Statistical fluctuations in our region might mislead us about conditions elsewhere. What we call universal laws might only be local laws, that happen to apply within our discernible house of cards. Measurements of the cosmic microwave ground provide some reassurance. The radiation is remarkably uniform across the sky, suggesting the universe is homogeneous on extensive scales. If our part were atypical, we would expect to see larger variations. The uniformity imply that what we observe actually is interpreter, at least statistically. Yet, the horizon limits what we can ever know. Here's the deal: questions about the universe's total size, its overall form, and what lies beyond the observable part may be fundamentally unanswerable. We can theorize and extrapolate, but direct observance is impossible. Certainly, the cosmos widen beyond our range, perhaps infinitely, and we can only examine the small portion accessible to us. This approachable component incorporate 2 trillion, galaxies spanning 93 zillion light-year. That's an immense sample, but it might represent only a tiny fraction of realism. Generally, most of the creation lie beyond the skyline, unknown and unknowable. The reality is we see rough 3% of the sum existence. Generally, the estimation comes from compare the size of the discernible universe, 93 billion light-year across, with theoretic calculations of the entire existence. If cosmic inflation go on, as model predict, the complete universe should be vastly bigger than what we can observe. Cosmic inflation was a period in the universe's number one fraction of a second when space expanded exponentially fasting. This rapid enlargement stretched the universe from subatomic scale to scales far larger than the stream observable area. Honestly, observation of the cosmic microwave background confirm that rising prices probable occurred found on the patterns in temperature fluctuation across the sky. If rising prices spread out the creation by at least 60 E-folds, as most model hint, the sum size would be huge. Generally, E-fold agency multiplying the size by close to 2.7. 60 E-folds, way multiply by that number 60 times in succession. Besides, the result is a universe at least 10 to the power, basically of 26 times larger than the observable region, perchance far larger. But here's what's interesting. Other estimates approach the question differently. Clearly, a statistical analysis published in 2011 examined various cosmological models and their likelihood give observational data. The examine concluded the creation is at least 250 times larger than the observable portion. In fact, that places the lower limit, more or less, DM at about 7 zillion light-year. Though eternity remains possible, these numbers are notional because we can only observe what lies within our cosmic horizon. Everything beyond is hidden. We can extrapolate found on the uniformity of what we see and the predictions of inflationary models. AIM verification is impossible. The full universe power be thousands of multiplication larger than we can observe or 1/10,000 of multiplication larger or space. And space creation has strange implications. If space extend forever, then every possible arrangement of matter exists somewhere. There would be infinite copies of Earth, space versions of the Milky Way, infinite instances of every galaxy we observe. Probability becomes meaningless when multiplied by infinity. Everything that can happen does happen immeasurably many times. Most cosmologists contemplate an infinite world plausible, perhaps flush likely. Also, the geometry of infinite appears flat according to measurements of the cosmic microwave ground. Flat infinite extending infinitely is the, essentially, simple model that fits the data. So what does this mean? Alternative models involving swerve infinite that closes dorsum on itself aren't ruled out. Take fine-tuning to match observations. Importantly, if the world is finite, it has a size we, essentially, could in principle step if we could observe beyond the horizon. But we cannot. Without question, the discernible universe defines our sample, and from that sample, we must, infer the properties of the whole. It is like trying to determine the size of an sea by examining a bingle drop of H2O. Importantly, the drop's properties tell you about H2O, but they reveal nothing about the sea's extent. Now here's where it gets good. The whitish way from this perspective become almost meaningless in graduated table. In fact, one galaxy among 2 billion in the observable universe. The discernible world itself possibly representing less than 1% of the totality potentially infinite at each grade. The previous scale shrinks into significance. Yet we live at a level where the Milky Way feels substantial. Light takes 100,000 years to cross it. Really, that span of time transcend all of recorded human chronicle by element of 1c. We evolve on a satellite orbit in Norm star in an average position within 1 Coltsfoot. Basically, That single galaxy contains more star than world can count, more worlds than we can visit in a billion lifetimes. Of course, the observable world contains structures so vast that describing them requires new vocabulary: superclusters, filaments, void, quite, traverse a century of millions of light-eld, and all of it power be a tiny fraction of something immeasurably larger. The scale defeats comprehension at every degree, essentially. But one comparison puts it all in position, relating the creation back to the world we cognize. Is the universe infinite? This inquiry divides smologists into competing camps. Obviously, though most evidence leans toward one answer, the geometry of space, confirmed precision measurements of the cosmic microwave background, look flat to within percent accuracy. Flat geometry extending infinitely is the simplest interpretation. The thing is, and space existence has no center and no edge. Every location is equivalent. The thing is, if you traveled in any direction forever, you'd ne'er range a boundary. Infinite only continues. But here's what's interesting. New galaxy, new structure, new regions, identical in their statistical properties to ours. Additionally, alone in their details. Now here's where it gets good. The pattern repeats endlessly. This creates a paradox called the cosmogonical view problem. If the universe is infinite and space is expanding, then regions separated by more than the cosmic purview have no causal connection. Surprisingly, they have never exchanged info, yet they look remarkably similar. The temperature and denseness of the cosmic microwave background is nearly identical across the stellar sky. How can disconnect region portion the same properties? And here's the thing, cosmic inflation solves this paradox. Before inflation, the evident world was petite, much smaller than it is now. Think about it this way. To be honest, all area inside the stream discernible world were in causal contact back then. They attain the same temperature and density through rule physical processes. Then rising prices stretch that small, essentially homogeneous patch into something immensely larger. The truth is, the regions lost causal contact during inflation, but they retained their initial uniformity. Frankly, this account works whether the pretty much universe is finite or infinite. If space inflation took an already infinite universe and made it exponentially larger, which is mathematically possible, rising prices stretch a small finite universe into a much larger finite one, if finite. In fact, either way, the result is a cosmos where the observable portion is homogeneous but represents only a small sampling of the total. Some models predict the universe is finite but unbounded like the surface of a sphere. The thing is, on a sphere, you can travel forever in a straight line and finally homecoming to your starting point. The surface has no bound, yet it has a finite area. A three-dimensional analog would permit travel through infinite to finally loop back, though the distances involved would far transcend the observable existence. Such a theoretical account requires space to be curved in specific ways. Measurements of the cosmic microwave background constrain curvature tightly. Indeed, if space curves dorsum on itself, the curvature must be so gentle that the loop is far larger than the observable universe. We subsist inside a sphere. If it is a sphere with a radius potentially billion of visible radiation, the curve is too gradual to detect locally. Basically, other models propose a multiverse where our universe is one bubble in an eternally expand space. Different bubbles have separate properties, different constant, different laws. Basically, we exist in one bubble where conditions pass off to allow structure formation and life. Beyond our bubble lie innumerable others, forever unreachable and unobservable. While the multiverse self is space, this scenario suggests our universe is finite. All these models stay speculative. We can only observe our local cosmic view. Whether space continue infinitely beyond, loops dorsum on itself, or terminates some unimaginable boundary is unknowable with current technology. Hereafter observations power tighten constraints, but the question may stay evermore unanswered. From a practical standpoint, whether the creation is finite or space matters little. The evident portion comprise enough galaxies, enough stars, decent space to exceed comprehension regardless. Look, 2 trillion galaxies spanning 93 trillion light-year already defies human intuition. Whether that represents everything or only a minute sampling changes about the enormousness we face. The Milky Way contains hundreds of billions of ACE. The thing is, the evident universe contains 2 million galaxies. Multiply those numbers. Think about it this way: 706 zillion adept at minimum. Now, here's where it gets good. Each star potentially hosting planets. The possibilities for worlds, for living, for civilization multiply into meaninglessness. If the universe is space, those already incomprehensible numbers get truly space. In fact, yet scorn this sweep over scale, we can comprehend our place inside it. We know our cosmic reference. We understand the hierarchy of structures. The reality is, and comparing that pecking order to man's scales reveals just how small we truly are. In fact, Earth measures close, kind of to 8,000 meters in diameter. Basically, that appear big to creatures walking on its surface. Mountains tower 1,000 of feet high. Oceans span thousands of miles. Basically, continents stretch across half the globe. Often from our perspective, Earth is vast. Scale up to the solar system. Globe becomes a blue marble following to a sphere of fire 100 multiplication wider. The distance from Earth to its star is 93 million miles. A gulf so huge that light issue 8 minutes to cross it. The solar system's edge, where the Oort cloud ends, sits nearly 2 light-years away. And here's the thing, Earth shrinks to an atom. Let me put it this way. Scale of measurement up to the Milky Way. The solar system turn invisible. 100,000 light-years from edge to border. The Coltsfoot contains 400 billion star systems. If the Milky Way were the size of North America, the solar scheme would be littler than a grain of sand. Earth would be invisible even under a microscope. Scale of measurement up to the local group. Certainly, the Milky Way become one of Tier's significant galaxies, in a mass 10 billion light-years across. Look, if the local group were shrunk to the size of North America, the Milky Way would be roughly the size of a quarter. And here's the thing, Earth would be smaller than an atom. Scale up to the observable universe, 93 million light-years in diameter. If you shrank Earth to the size of a virus, close to 100 nanometers across, the discernible universe would scale to approximately the size of our solar scheme. A virus compared to the distance from here beyond Pluto. That represents the scale ratio between our world and everything we can detect. Another comparing makes the point differently. Count every cereal of sand on every beach and in every desert across Earth. The sum approaches 7 quintillion grains, close to heptad followed by 18 zeros. The observable world contains approximately 76 trillion stars, 100 multiplication more stars than cereal of sand on Earth. Indeed, each star potentially hosts multiple planet, manifold the number of existence far beyond comprehension. Clip offers another lens. What's more, if you compress the world's 3.88 billion year history into a 112 month, the first adept would form around January 15th. The whitish way would assemble by early March. Our solar system would appear on September 1st. Generally, complex life on Earth would emerge in mid-December. Honestly, dinosaurs would roam from December 26th to 30th. Modern humankind would appear in the last 30 seconds before midnight on December 31st. All of human civilization, every empire, every uncovering, every war survive in the final fraction of a second before the year end. Everything we evaluate ancient story happened in the blink, sort of an eye compared time scales. Globe itself is young compared to the universe. existing for only 1/3 of cosmic chronicle. What's more, the atoms in your body are older than Earth. The thing is, carbon formed in stars that exploded billion of age ago. Atomic number 1 in your water formed minutes after the Big Knock. You are made of recycled stellar stuff. Importantly, that once floated in interstellar clouds, fallen into earliest generations of ice, forged into heavier element, and scattered into infinite when those stars died. Every breath contains atoms that were once portion of remote stars. This realization shift perspective. We aren't separate from the cosmos. We are the cosmos examining itself. The existence-generated star, then satellite, then chemistry complex enough to produce living things, then consciousness capable of understanding its origins. We are the mechanics by which the universe knows itself exists. Yet despite this connection, the scale gap remains overwhelming. Earth, the whitish way, even the local supercluster vanish when compared to the observable universe. And the observable universe itself power be a negligible fraction of the total. At each level of zoom, the previous scale becomes a point too small to see. Plus, this raises the question that has troubled philosophers since humans first looked up at space. Why does the creation need to be so large? Visible light travel at 86,000 meters. Nothing moves faster. In fact, this speed boundary, sustained by countless experiments and woven into the structure of spacem itself, defines how quickly information can propagate through the universe. It also finds out what we can observe. Get 13.8 billion years ago. This age is confirmed through multiple independent measurements, include the cosmic microwave background temperature, the abundance of light elements, and the enlargement charge per unit. Visible light has only 13.8 billion years to traveling. This set an absolute limit on how far we can see. Flush without expansion, this limit would restrict observations to an orbit 27.6 billion light-years crosswise. But expansion infinite, increasing distances while visible radiation travels through it. This pushes the bound outward to 46 billion light-year, the current radius of the observable existence. Beyond that distance, light has not had clip to reach us, no matter when it was emitted. This creates a moving boundary. Every second, light from slightly more remote part completes its journey and scope Earth for the first clip. The discernible universe turned by 3 light seconds per second, of 560,000 meters. Over the course of a Homo lifetime, the observable world expands by billion of mile. New galaxies appear at the bound of visibility as their ancient light finally arrives. Without question, but this growing won't go on eternally. At the end of the day, the quickening of expansion set a maximum future observable range at close to 62 billion light-year. Galaxies presently beyond this distance are receding too fast for their visible light to always range us. Notably, as clip pass, more and more galaxies will cross this threshold and fade from seen. Observable universe will eventually wither, not grow. In 100 zillion ELD, confirmed through projections based on current enlargement rates, observers in our galaxy will see immensely emptier sky. Most galaxies will have redshifted beyond SBL. The cosmic microwave background will cool until its radiation reaching to wavelengths too long to discover. At the end of the day, infinite will appear wickedness and silent, except for the fistful of galaxies in our topical anesthetic gravitationally bound group. Future civilization arising in that era will have no way to discover the Big Bang. What we're seeing is, the grounds will have literally expand beyond the skyline. Basically, they'll measure the motions of nearby galaxies and find them gravitationally bound, viewing no enlargement. Actually, they conclude the creation is atmospherics, eternal and restrained to their local cluster. All grounds of the universe's true-up nature will be inaccessible to them. This make a troubling possibility. Also, possibly we are already in that situation. Perhaps grounds of the existence's origins or its ultimate nature has already expanded beyond horizon. Besides, question we consider core power be unanswerable, not because they're too difficult, because the relevant information has been carried away by enlargement. Usually, we could be miss crucial pieces of the puzzle without knowing they exist. The cosmic horizon besides bound what we can learn about the universe's and topology. If space curves back on itself, but the curvature radius exceeds the observable universe, we can never detect it. Really, if the universe has exotic topological properties, repeating pattern larger than we can see, we remain ignorant. Our sample is limited, and extrapolating beyond it requires assumptions that may prove wrong. CLIP also limits how far into the yesteryear we can see. The cosmic microwave oven background come from 380,000 years after the Big Bang, when the universe became transparent to light. Before that instant, infinite was opaque, a hot plasma that absorbed photon. We cannot see earliest multiplication with electromagnetic radiation. The number 1, 380,000 age remain hidden behind an impenetrable veil. Gravitative waves might let's heyday further back. Here's why this matters. Plus, these ripples in space-time traveling unimpeded through thing and radiation. Primordial gravitative wave from the number 1 moments after Big Bang could still be propagating through the universe. Detecting them would open a window to epochs invisible through any other means. But the signals are extraordinarily weak, requiring detectors far more sensitive than current technology allows. Our view of the existence is essentially limited by time, by the speed of visible radiation, and by the acceleration of enlargement. Without question, we see a finite area during a finite window of cosmic chronicle. Sampling contains 2 million galaxies and span 93 billion light-year. Look, it is vast, but its power stand for only a fleeting glimpse of something immensely larger and more complex than we can currently comprehend. Frankly, the question remains, if our observations are so limited, what lie beyond? Beyond the cosmic view stretches space we will ne'er observe. Light from those regions has not reached us, and due to accelerating expansion never will. That space could be similar to what we see, governed by the same laws, filled with galaxies arranged in the same cosmic web form. It could be utterly different. Some inflationary models predict a multiverse. During eternal rising prices, quantum fluctuations cause some regions to stop inflating and generate bubble creation like ours. So what does this mean? Other regions continue inflate forever, spawning new bubble continuously. Each bubble becomes its own universe with its own physical properties. Our observable universe is one bubble in an infinite foam. Various bubbles could have different physical constants. No doubt, the strength of gravity might vary. Frankly, the mass of electrons could differ. The number of spatial dimensions might not be 3. Most bubbles would be inhospitable to life, their physics failing to produce stalls atom or stars. We live in a bubble, can pass off to allow complexity. This scenario makes testable predictions. If our house of cards collided with some other in the past, the collision would leave a signature in the cosmic microwave background, a significant circular anomaly. Searches for such anomalies have found nothing conclusive so far. Either collision haven't occurred or the signatures are too subtle to detect with stream instruments. Another theory suggests the creation is cyclic. It expands, then contracts, then bounces into a new expansion form. Each cycle erases grounds of previous ones. We live in the current enlargement phase, unaware of innumerous cycles before or after. Certainly, this model eliminates the need for an initial singularity and explicate why physical invariable return the values they do. They evolve through cycles to establish stable universes. The cyclic model faces challenges. Randomness increase with each cycle, building up until the existence can no thirster bounce. unless some mechanism resets entropy. Basically, the cycle must have a beginning. That beginning leads back to the same questions about initial conditions that cyclic model attempt to avoid. A more radical idea proposes the universe is a hologram. All information contained inside a mass of space is encoded on its boundary surface, like a holograph encoding three-dimensional images on two-dimensional film. Applied cosmologically, this way our three-dimensional existence and everything within it is a projection from information stored on a two-dimensional surface at the cosmic horizon. Evidence for this comes from Inkiness whole thermodynamics and attempts to reconcile quantum mechanics with gravity. Basically, the mathematics suggests realness has few main dimensions than we perceive. What we as three spatial attribute could be an emergent property of a let-down dimensional scheme. Tests of this idea examine whether physical process display signs of underlying two-dimensional structure. Results so far are equivocal. All these theories stay high risk. We can only observe our local anesthetic cosmic neighborhood. Extrapolating beyond requires assumption we cannot verify. The universe power be one bubble in an eternal multiverse. But here's what's interesting, or it might be everything that exists. Truth is, it might be cyclic holographic, or something we haven't yet imagined. Now, here's where it gets good. Without question, stream observations cannot distinguish between these possibilities. What's more, what we do know is the discernible universe contains 2 million galaxies, each with billions of stars arranged in a cosmic web stretch 93 billion light-year. That structure formed from tiny density fluctuations in the early existence, amplified by gravity over 13.8 trillion years. Dark matter provides the scaffolding. Darkness energy accelerates the expansion. Ordinary matter soared galaxy, adept, planet, and finally living. The Milky Way sits in this vast, essentially, creation as one coltsfoot among billion. Frankly, our position isn't central or special. We orbit an average star in an average location inside an average galaxy. What's more, yet from this average location, we have mapped the structure of the observable universe. We have traced our cosmic address from Earth to solar scheme, to galaxy to local group, to Virgo supercluster to Laniakea. We comprehend the hierarchy, and we have realized that hierarchy might extend forever in both directions. Here's the deal. Smaller structures inside atoms molecule, force we haven't yet observed, larger structure, more or less, shape we cannot find, scales that make superclusters face like atoms. The world power be fractally infinite with no smallest or largest scale, only levels we can currently access. The reality is, but regardless of what lies beyond observation, we can comprehend one profound truth about our place in the cosmos. The Milky Way is 100,000 light-year crosswise. The observable universe spans 93 billion light-year. The actual universe might be space. Plus, these numbers define our spot in the cosmic hierarchy, and that property is humbling. To be honest, we live on a planet 8,000 meteoroid, orbiting a star that's one among 400 billion in our coltsfoot. That galaxy is one among 2 trillion in the discernible world. The discernible universe power be a tiny fraction of the whole. At each level, the significance of the previous grade diminishes towards zero. Yet here is the paradox. Contempt occupying such an space decimal place, we understand the construction surround us. Humans to one planet have mapped the cosmic web. We have measured distances to galaxies million of light years away. We have traced the story of the universe rear to moment after its outset. We have glimpsed the underlying architecture of reality. This represents an achievement almost, basically, as improbable as our existence. The universe has no obligation to be comprehensible. Of course, physical laws could have been random, eucognes, disorderly, impossible to decode, or else they follow numerical patterns we can discover. Nature isn't deliberately obscure. It answers questions for those who learn to ask properly. Our comprehension comes from light. Photons travel across cosmic distances, carry information about their sources. By collecting and analyzing these photons, we reconstruct the universe's contents, distances, and evolution. Light returned billions of years to range us. But when it arrives, it states stories about galaxies, a depth, and the spaces between. Actually, we are archaeologists excavating the past through astronomy. Plus, the scale gap between world and the discernible universe mirrors the scale gap between atoms and humans. And speck compared to a human is alike to a human compared to the Milky Way. We survive at intermediate scales, neither smallest nor largest, able to perceive both direction. This middle position allows perspective. We are small enough to be humbled, significant enough to recognize. Look, no, our cosmic address changes null about daily living. Soberness still pulls. Light source hush travel. The laws of physics that govern galaxy are the same laws regulate disobjects on Earth. The universe operates consistently across all scales we can measure. This consistency suggests the laws we discover aren't merely topical anesthetic accidents, but key properties of reality. No doubt, it besides suggests we aren't alone. 2 trillion galaxies, each incorporate billion of stars, connote trillions of survive in potentially habitable zones around their star. What's more, the chemical science of life uses commons elements formed in a depth throughout the universe. Now, here's where it gets good. Importantly, the same physical processes that led to living on world should occur elsewhere. Whether that living develops intelligence, but the raw numbers suggest billion of opportunities. Let me put it this way. If other intelligences exist, they see the same universe we do from their own vantage points. Importantly, they observe galaxy receding, step the same cosmic expansion rate, discover the same dark affair and dark energy. The universe doesn't hide its nature. Plus, any civilization that looks carefully will uncover like truths. Let me put it this way. Naturally, we might be isolated by distance, but we are connected by shared uncovering. Our place in forever is this. We exist briefly on one cosmos in one galaxy, in one supercluster, in an observable bubble that represents a tiny fraction of a perhaps space existence. We are temporary concentrations of matter that have become aware of themselves. The atoms in our bodies formed in prima furnaces, really, and will return to infinite when we die. We are the universe experiencing itself, comprehending itself, measure itself, that we can understand even a fraction of the structure surround us is remarkable. That we evolved the capacity to ask these questions is statistically unconvincing. That the universe allows us to answer them propose something profound about the relationship between cognizance and realness. The Milky Way is vast beyond intuition. The observable world is vaster beyond comprehension. What lies beyond might be space, and somewhere inside that immensity on a small rocky universe beings evolved, who can realize the scale of their cosmic neighborhood. That grasp doesn't alteration the scale. It doesn't make us larger or more significant. In fact, but it means the existence isn't just physical. It contains meaning. And that meaning survive because we are here to recognize it. We are spatial fraction. We are impermanent. We are insignificant by any measure of size or duration. And here's the thing. And yet we have, pretty much, mapped the structure within which we are embedded. We know our address. We comprehend our place. And that discernment, fragile and incomplete as it might be, represents consciousness reaching across cosmic scale to glimpse the architecture of everything. The evident universe incorporate 2 trillion galaxies spanning 93 trillion light-year. The whitish way is one of those galaxies. Earth is one planet in that galaxy. What we're seeing is, you exist on that planet for a brief minute of cosmic clip. And during that moment, you can look up, See visible radiation that has traveled for billions of old age, and comprehend the journey it took to reach your eyes. That's your spot in forever.